Good day. Welcome to our webinar and thank you for joining us today. I am Evelina Parisi, Inside Sales Representative and Marketing Assistant of Aerofins Tecna. Aerofins Tecna is a company based in Italy belonging to the Aerofins Technologies division, where screening test kits for mycotoxins are developed and validated. With the goal to simplify the routine analysis of industries and laboratories, today we are asking to Julia Rosar, our product manager, to provide with an overview of available screening solutions and focus on their application to automatic analyzers.
Indeed, Evelina, thank you very much for your nice presentation and introduction. Today, I am going to talk about available technologies for mycotoxins analysis and also how to do they fit with different requirements and needs in terms of time to result, analytical complexity and capacity, cost, and ease of use. Then I will make a brief overview on ELISA test kits that are available from the Eurofins Technologies portfolio. We have different assays formats to better adapt to customers' need. And finally, I will describe how we can simplify the routine of both small and big laboratories and industries as well through one ELISA robot.
So thanks, Julia, and let's start. And yes, I would like just to break the ice, asking if are Aerofins Technologies ELISA test kits suitable to be run on any automatic analyzer?
Well, we have very easy ELISA test kits. I don't see why. I don't see any specific reason why they should not work on any automatic analyzer if they are equipped with a reader at the 450 nanometers filter. Nevertheless, I am going today to focus on one specific instrument that you see here in this picture, that is the bolt. This is a very compact instrument owned by Eurofins Technologies as well, where we were able to successfully validate our ELISA test kits. This is, in my vision, a real benefit for end users.
And why? Why do you think that?
You know, automatic analyzers must be programmed to do what you really want you would really like them to do, and then you are supposed to verify if what you programmed is consistently giving you reliable results. So usually this operation could be significantly time consuming for laboratories and industries, should be done in a moment of low analytical volume, in my vision. And it could also turn to be expensive. You need to consume some test kits just for such investigations as such adaptation. So in this very case, that Eurofins Technologies is able to provide a turnkey solution. You can really implement this test and on the robot right after the robot installation. And I am going to show in the presentation how we perform the validation and which parameters we decide to investigate to be sure and confident about the performances of our test kits once they are run on the bolt.
Perfect. So excellent, Julia. Then, before we start, let me remind our audience that you are all muted, but you can find the chat box in your screen where you can drop us questions anytime. At the end of the session, we will do our best to answer your requests. So, Julia, please, the stage is yours.
Thank you then, Evelina. Thank you very much. Thank you to the audience that have connected to us. So let's start. As you know, this is a very classic overview. Mycotoxins are toxic compounds that are naturally produced by different types of fungi. Mycotoxins enter the food chain as a result of infection of crops before and after harvest. And they are typically found in foods such as cereals, dried fruits, nuts, and spices, and so on. Also, they can be present and have also relevant concentration on commodities and half-processed ingredients used for animal feed production. The presence of mycotoxins in food and feed may cause direct adverse health effects in humans and animals, ranging from gastrointestinal and kidney disorders to immune deficiency and even cancer. Exposure to mycotoxins can happen by eating contaminated food from animals that are fed with contaminated feed as well. So the most important example in this sense is the contamination of milk with Aflatoxin B1 metabolite that is called M1, M because of milk. So the most common mycotoxins that pose a concern to human and animal health include these listed that you see here: aflatoxins, ochratoxin A, fusarium toxins like deoxynivalenol. Their growth is impacted by temperature and humidity condition, and let me underline that under the same conditions, different molds can grow and produce also several patterns of toxins. So the presence of multiple mycotoxins in food products has been reported worldwide for a variety of different food materials. Surveys on co-occurrence of mycotoxins indicated in some cases that over 50%, more than a half of contaminated samples contained more than one mycotoxins. There is another story, on the other hand, that the increased knowledge and definition of the correlation between weather conditions and mycotoxins growth have brought to several available predictive tools. And this means that farmers are now in the position to define their own risk assessment, and they usually select and put a closer attention to those compounds of highest risk. So in this complicated situation, which are currently the analytical technologies that are available at this state of the art? So rapid tests are sometimes called also strips or dipsticks. They are based on lateral flow immunoassays. They're very simple and fast screening tools that are, I would say, really widely used for on-site sampling of and goods verification at acceptance. At the beginning, their original task was to proper classify crops batches by detecting those uncompliant lots from those that are acceptable. A good screening tool was supposed at the beginning, to have in this sense a low false compliant results incident, as this may pose a risk to human and animal health, but also at the same time a low false positive results ratio, as this represents usually a cost for the producer. You misclassify a good batch that could be used, you think it is contaminated, you have to confirm, and then you realize that it was fine, it was safe. While at the beginning, such kind of screening tools were considered more as a qualitative tools, with yes or no answer, positive or negative. Now strip tests are really available as fully quantitative, with almost very good accuracy and precision and high correlation with instrumental analysis. So this way, the samples can be analyzed with different decision limits. There is not a fixed cutoff established by the producer of the strips, and they can be used not just to determine if a batch is contaminated or not, that maybe is not that meaningful. They are useful also to determine and handle those batches that maybe are compliant but need some further sorting or cleaning. or some process, or those ingredients, raw materials that can be used for different purposes depending on their contamination. So as at the beginning, you just had this discrimination as in the box of green or red situation where you had goods that were compliant or not. Then you can have also the gray zone, like the yellow boxes, where proper handling is needed. While strip tests are very easy to use, rapid, and intended for on-site screening, on the exact opposite side, we have instrumental analysis based on chromatography that is used as confirmation, used mainly by service laboratories and some official control bodies, and also some big food and feed industries are equipped with such kind of instruments. Liquid and gas chromatography require a relevant investment at the beginning, good training, routine maintenance, a certain expense for consumables because samples need to be purified before being injected on the instrument. But this way, on the other hand, the analysis allows not just to have a quantification of overall amount of certain toxins, but also pattern and the characterization and identification of which compounds are inside a certain sample. What in the middle between these two opposite fronts? ELISA test kits are excellent tools for a very low cost screening with a pretty flexible throughput. ELISA as a technique can be hosted in plants and industries to validate offline and verify the strip test results, for instance, or to verify the compliancy of single farms upon acceptance of commingled batch, as it happens regularly with milk analysis, for instance. So when the tank arrives in a company, the strip test provide immediately a feedback whether you can accept and use that commingled milk that belongs to different farms, for instance, and then in the afternoon, for instance, with no rush, you really can analyze through ELISA the milk that is coming from different farms. They are also low-cost solutions for the verification of stock materials and process verification also, where strip fastness is not needed. And also, ELISAs can find good applications and laboratories aiming to offer some low-cost options to their customers, or needing, I don't know, a technique to enhance their analytical capacity, or maybe kept in combination with instrumental analysis, limiting to the confirmation only those suspect samples.
Julia, do you have any insights on multiplex solutions?
You're right, Evelina. This is missing in the presentation, but for more than 10 years, I would say, there have been some launches, some attempts to provide the food and feed production chain with multiplex analytical technologies. And the idea, in my vision, is great. You can really exploit one sample, meaning one sampling procedure, one grinding step, one extraction, and then you use that very material, that very extract, for getting a complete profile of mycotoxins content. And I think it would add really a value on our knowledge and also to our risk perception, for sure. But at the same time, I also think that such kind of approach must be very convenient, easy to perform, and fully flexible. So food and feed companies, as I was mentioning before, they do want to search for certain molecules only based on their risk assessment, on their studies. And then they really don't aim to spend more to learn that for a certain parameter, for a certain toxin, they have all compliant samples. They really don't care. So what I can report is that there are a few multiplex technologies available. Yes. Well, for the rest, I do see mostly open platforms of strips, so lateral flow devices and ELISAs, maybe sharing common sample preparations throughout all the mycotoxins and letting, in the end, the analysts totally free to run only the analysis they want to do. So only the toxins they want to search for. Okay.
Okay, yes, so thank you, Julia, please.
So I am going to present the concept behind the 4 lines of ELISA test kits for mycotoxins available from Eurofins Technologies. So despite the fact that we are just talking about ELISAs, that is a pretty old technology, you see that we have declined our portfolio in several versions to meet different needs and enhance different peculiarities, different features. And this way, we are really able to target the right product to each kind of different need. So, okay. The first line I would like to present is named B0. Because in each kit, you won't find any calibrator apart from the 0 standard. That is the blank, the uncontaminated standard giving the maximum signal. I have developed this line of test kits for Aflatoxin B1, deoxynivalenol, zearalenone, T2, H2 toxins, Ochratoxin A, fumamizins, and Aflatoxin M1, because we wanted to provide customers with something that was really cost efficient for their screening. So you see on this very scheme here, when you run a few samples in a session, the amount of wells that you need to dedicate to the calibration curve is definitely not irrelevant. And it impacts in the end, the overall expense that you have for your quality. For low analytical throughputs, the B0 format is the only affordable solution, as one single well is dedicated for each sample, plus you have to run one standard only per session. The intensity of the 0 solution that you get at the end of the assay will permit you to calculate the relative signals for samples and will mitigate the impact of environmental factors like, I don't know, the temperature variation in the laboratory. The rest is done by the robustness of reagents. That is really the key for this kind of assays, as the sample quantification is permitted in the end by means of a batch-related virtual calibration curve that we set at the beginning, at the moment of the batch release, and is valid throughout the whole shelf life of the kit. This product line is very convenient, also considering that for native toxins and vegetal samples, so all these lists apart from Aflatoxin M1, you have a common sample preparation, done included, that allows you to exploit one single extract that is based in methanol, water, and salt, and you can use this extract on the whole platform. For Aflatoxin M1 and milk instead, you don't have any sample preparation at all. So you don't need to centrifuge, to remove the fat, to dilute, to do whatever. You simply take the milk as it is, both of bovine origin or caprine or ovine, doesn't matter, and you run directly into the assay without any sample manipulation. So this line is providing really fast, because less than 30 minutes assay, accurate results at the lowest possible price. And I do see them as valid support for industries and small laboratories also. The newest line of ELISA test kits that were developed by Eurofins Techna is the water-based series. And here the goal is very easy to understand. We wanted to remove the solvents from sample preparation and kit content, so also from the calibration curve. We currently are able to offer one water solution for DON and one for total aflatoxins, where you cannot extract in water, but you have to use a buffer that is provided in the kit. So obviously DON is a water-soluble mycotoxins. Water extraction is normal and not really an innovation. For total aflatoxins, I have to say we had our own challenges to guarantee consistent recoveries throughout the whole dynamic range. But we were able really to set up a very good product with leading to fast results because the assay is just 10 minutes long. We are using a very broad range sensitive antibody that is able to detect the 4 aflatoxins, B1, B2, G1, and G2 with very consistent cross-reactivity. And in the end, we were able to develop an efficient extraction procedure without using any solvent, neither methanol nor ethanol, leading to really consistent results and almost without any underestimation issues. Both this H2 DON and H2 AFLA are available in regular format, so with calibrators included in the kits, and also in the B0 version, so you can also decide to go for the low-cost version with the virtual calibration. Then we have the seller line of ELISA test kits to cover all the regulated mycotoxins. And this is a very classical assay format. We have 5 standards included in each kit. The execution is very simple, does not require any use of replicates. So you spend 1 well per each standard and 1 well for each sample. There is one common sample preparation for cereals that is indeed in common for the kits for Aflatoxin B1, total aflatoxins, fumonisin, T2, zearalenone, DON, and ochratoxin. And this again, like in the case of B0, Evelina, it's exactly what we were talking about earlier. This allows us somehow to have a multiplex solution that is really flexible and easy to use, as the same extract can be flexibly run onto the whole kit series. The kit allows to obtain the results in 15 up to 20 minutes, so they're definitely pretty fast. And also, as you can see on the picture here on the right side of the screen, these kits have been fully validated on the Bolt. That is this very compact automatic analyzer from Eurofins Technologies. You see here in the picture there are some features. It is 100% open instrument that is able to host potentially any kind of plate-based immunoassay, not just for mycotoxins, definitely. And it has a very user-friendly test designer and software that is able to work on almost every kind of assay. And once it's programmed, it allows the automatic run of ELISA in a fully walk-away mode once the session has started. So the technician really goes away and the robot does the analysis. But before moving into the automation chapter, that is going to be interesting at the end of the presentation, I'm concluding with a presentation of the 4th line of test kits, that is the ice cream. And this kit seems the old-fashioned, the seasoned test kit line with longer time to result. But for Aflatoxin M1, we are able to provide the only word-approved test method from AUSC International. So this kit is very sensitive. It has a limit of quantification 10 times lower than the European limit and 100 times lower than the Food and Drug Administration action level for Aflatoxin M1 in milk. That's very accurate, precise, with a very good correlation to instrumental analysis. And indeed, it was granted the status of performance tested method by AUSC last year for the quantitative detection of aflatoxin M1 in raw milk, defatted milk, and milk powder. So I think it's really an excellent product for milk screening. There is another version that is iScreen Aflam 1, and it is addressed for the analysis of all dairy products like cheese, yogurt, sour cream. This is a comprehensive kit format that includes all the protocols and buffers also needed for such kind of analysis. And both kits that rely on same reagents in the end and have the same assay layout and so on. Both versions have been fully and successfully validated on the Bolt analyzer. So I think that now we have to talk about the Bolt. As already mentioned, the Bolt is a very compact, easy to use and flexible ELISA robot. It has a highly precise dispensing nozzle and it hosts one plate plus one premixing or pre-dilution position. But in the end, you can host even multiple protocols in parallel in the same session if they can be hosted in the same plate frame. This robot means that can be easily adopted also for low and medium analytical volumes, because also it does not represent an investment, you know, that has sense just for big laboratories only. By a technical point of view, it hosts all the steps needed by any classical plate-based immunoassay. So it's able to obviously pipette, incubates. It has a shaking option. It runs the washing steps autonomously. It has a warm-up station, and the reader also is built in. With different wavelengths filters available, and the software automatically calculates the results with several available algorithms. Being a closed system, it ensures a protected environment and to the assay. On this, in the end, the guarantee is also excellent assay reproducibility over the time. And being a robot, being an automatic analyzer, it reduces the risk and the cost related also for human mistakes. It guarantees some free time to the personnel, and in this very period, I would add also that supports the social distance that must be kept in and also in the workplace. So the analysis of mycotoxins on the Bolt is very easy. For milk analysis, you have to take your samples, just drop them into suitable containers, tubes, or appender tubes or whatever, and load them into the instrument. For cereals and vegetal samples, you have to run one short preparation that is uncommon among the wholesaler line of test kits. Then you have your extract and you add into the machine, and you match each of your extracts to the right seller method you want to run. So in the end, once you have selected all the method, one method or more methods, up to 4 different methods can be run in parallel. in the machine, you start the run, you can really go away, you're free to do your own task, and in the end, when the analysis is finished, you will get your own full report in PDF. You can store, save, print, and so on.
Sorry, Julia, for interrupting, but I just seen a questions, and I see that maybe this is the appropriate moment to mention now. We are asked if the run can be set overnight, and the answer, I think it's yes, correct?
Yes, sure, Evelina. Yeah, made it a good option to interrupt. Yes, the instrument can work during the night, and we also did it in the past. And in the morning, when you come back in the laboratory, you get your instrument settled down, let's say, but everything is finalized. So you get your result, and your report is ready. Yes, sure. That's also possible to do this way.
Yeah,
So,
perfect. Nice way to spend the evening. So, okay, please
yes,
go on.
indeed. Thank you. So the Bolt comes with an open test designer. So it means that allows to program each kind of assay with all prescribed steps that are usually included in each kit manual. The interface is really friendly and allows a very high degree of freedom to adjust and refine the protocol. This is needed because you have to think that in the end, the robot is not a technician and has, certain function, but cannot act like a human being. So that the protocol usually has to be indeed refined and perfectioned before being ready for routing analysis. And so after having a protocol ready, in our vision, it must be validated. So what does this mean? In our experience, it is really important to check that a protocol is leading to compliant calibration curves, compliant sessions, let's say, that it is free from cross-contaminations issues, does not lead to any drift effect, and ensures accurate and precise results, and can handle in the end hundreds of routine real samples. I mean, routine matrices, not just standard solutions. Well, for the rest of the other assay features, like, I don't know, the cross-reactivity, the matrix effect, these are not really impacted by the fact that the assay is run by a machine instead of a human being. So these are the parameters that in our experience are affecting mostly the experience of the end user when they shift the analysis from human technicians to an automatic analyzer. And we did exactly this kind of exercise for all our seller test kits and also for the iScreen Aflatoxin M1 kits, in order to be able in the end to provide customers with really ready to use solutions, something that can be exploited immediately after installation. So I do believe that the best way to describe this process is to follow what we did for one kit for iScreen Aflatoxin M1 milk, and inspect our results and discuss also why we did a certain way. So first, we set up the program and adjust to reproduce the steps that are prescribed in the kit manual, as you can see here. On the left, there is the manual prescription. So the assay, as usually run, manually, you have to pipette 100 microliters of standards and samples in the plate, incubate 45 minutes, then you have to wash 4 times with squeeze bottle with the washing buffer. Then you add the conjugate and incubate 15 minutes, wash again for 4 times, add 100 microliters of developing solution, incubate 15 minutes, stop, shake briefly with your hand, and then you have to go to the reader and read at 450 nanometers. The bolt method almost replicates exactly the same steps, but you see that for the washing steps, we optimized and changed a little bit the volumes used to wash the wells. And this is indeed because there is no squeezable water inside the sorry, inside the bolt. So our technicians, our researchers, they did exactly this exercise. They started with similar washing procedure and then they optimized. When the final method was obtained, we went and inspect the compliancy of some sessions. We did it by comparing the curves that we obtained manually to those that we were able to record onto two different machines. So we used two bolt units. One was located in our laboratory and the second one was at a customer site. So you see on the table, we have the parameters, the specifications that are included in the kit insert and must be respected by every session. The mean absorbance, the mean absorbance of the standard 0 that must be above 0.7 OD, the position of the B of 0, 50%, so the middle point of the calibration that must be in that very range. And also the coefficient of variation of standard must be averagely lower than 6%. You see the manual run results that were fully compliant and nice. They were obtained for 12 independent sessions. And then we collected 9 curves on bolt number 1 where exactly the same absorbance of standard 0 was obtained. Pretty similar positioning of the curve and compliant standard coefficient of variation. I would say that in all these cases, the variability collected among the sessions is definitely lower. So we have a lower standard deviation in the end if you really pay attention. Same for the second bolt that was located at the customer side, always compliant results and very compacted sessions, one close to each other. So we see immediately which is the advantage of having an instrument replacing a human being, that all the sessions are equal one to each other. So we can say that our method that we set previously is working properly, at least it is leading to compliant session. What about the dispensing unit? This is a tricky point. How can we prevent any cross-contamination issue? You know, during manual assay implementation, you use usually disposable tips, but the robot can't. This one does not have disposable tips. And so it has to wash the jet, the nozzle, after dispensing each component, each reagent, each sample. An efficient washing for sure prevents in the end to discard dozens of tips per session. We can calculate that a routine dairy laboratory running, I don't know, around 30 samples per day wastes uses around 15,000 tips per year. So these are savings related to the use of the bolt. But we have to be confident that the washing efficiency is sufficient, and once the robot dispenses something that is highly contaminated and then there is a negative sample, the negative sample is not contaminated by traces of some contaminant that has remained inside the nozzle. So for this reason, we arranged such kind of verification. This is the design of a plate where we ran first the standards and then a pattern of non-contaminated, middle contaminated, and highly contaminated samples, where we wanted to double check whether the accuracy was maintained, and also that the blank standard samples run after highly contaminated materials remained returned fully blank results. And we could confirm that the washing efficiency of the nozzle was demonstrated, was obtained. We are not able to define any influence of what is pipetted by the nozzle, by the jet, because the accuracy is kept and there is no trace of any kind of cross contamination. You see here for the milk, and we did exactly the same for all the other toxins that we used, that we validated for the cellar, for each kind of mycotoxins that we validate. Then we have to talk about the drift effect. The drift effect is a systematic mistake that is very often related to ELISA robots, and it produces a difference in terms of result when the same sample or solution is pipetted close or far from the calibration. And it depends in the end on some differences, on some drift in the reaction time. As I was mentioning, you know, a robot is not a human being and cannot at a certain point use a multi-channel pipette to add rapidly a reagent on a whole plate in one moment, for instance. So it must run every step one after each other, and it takes a certain time, of course. So we wanted to be sure that the sample that is dosed at the very end of the plate, of a whole plate, will be not affected by its position, and that is very important. So to demonstrate this, the lack of drift effect, to validate this aspect, we used two different control materials. They were powdered milk materials that we purchased, and we alternated, making sure that the same material was the first and the last one pipetted. And we verified that there was no drift effect, no trend in terms of absorbances or dosages. That means that this very well and the last one are in the end incubated in the same manner, and so the same reaction is granted no matter which is the position of the sample. So we can say that we demonstrated also the lack of any issue in terms of drift effect. Then obviously it is necessary to verify the accuracy and the precision when running samples matrices. And this very case, we wanted to use milk both as whole native milk with natural content of fat, and also we defatted as it is recommended by the ISO guideline. So we compared the results. We have demonstrated in this very case during the AUEC verification that with the manual execution of the kit, there are no really differences in terms of performances for this kit, if samples of milk are defatted or not, so if they are centrifuged or not. But we wanted to check that the automatic implementation was not leading to an issue. And indeed, you see that we got almost exactly the same performances on whole milk and defatted milk, no matter which was the concentration spiked and the treatment that the sample received. Also, we added 6 control materials we collected from 2 Italian providers of powdered milk with assigned value. These values are assigned through proficiency testings. And again, we obtain comparable results in terms of accuracy and variability. So the robot actually is not affecting at all the accuracy and the precision of the system of the assay, no matter if we are analyzing a whole bovine milk, defatted milk, or reconstituted powdered milk. Finally, I want to point out that one machine that was installed at the customer side was used to run around 600 of raw bovine milk routine samples that they were loaded in the machine as they were collected from the tank from the farms. So the natural content of fat was not removed. The samples were received and simply dropped into the machine and analyzed in parallel as per their routing with our test kits implemented manually. What we wanted to see here is the point was if the instrument would have suffered of any contamination issue, clogging or fouling. We are aware that this sometimes happens with some automatic solutions when real matrices and fat milk is pipetted time over time over time. So you see here in the graph the correlation that we were able to collect from samples that were run manually and in parallel in the bolts. So we almost collected the same results. Some of them were also highly contaminated with Aflatoxin M1. Some results were obtained manually and automatically. We calculated that to run 550 samples, the bolt saved more than 20 hours of human work and more than 1,000 tips that were not disposed and not discarded for these analyses. So I think it's really a huge benefit in this sense for milk analysis. Generally speaking, I see really many benefits related to the adoption of a validated automatic solutions for mycotoxins. For laboratories running many samples, this is obvious. This option prevents manual mistakes. It reduces the pressures on technicians. It saves consumables like tips and obviously supports the standardization of the performances. We have seen how close were the sessions one to each other day by day, no matter which were the variation of the environment and so on. But this very solution, this bolt, could be really of benefit also for low analytical volumes. It is very supportive, especially when a mix and match approach is needed. So if you're familiar with ELISA implementation, you know how easy it is to interchange standards when you have everything like a little big mess in your laboratory. You can interchange reagents when you attempt to manage multiple small session in parallel. You know, you say, okay, I just have a couple of extracts, I have to run 3 tests, so I can do them all together. Yes, what happens in the end that you can really take one bottle, mismatch some bottles, or you can modify the incubation time, for instance. My personal experience, I can tell you, is that I tried to keep everything under control, and then obviously when incubation ended and I was still washing the first one, and so the second would have waited, and I cannot tell you about the third one. Everything is managed automatically by the robot that is not induced to try to do what is not possible. It calculates exactly the timings and run the analysis with no mistakes and no modification over incubation times and so on. Such automatic platforms support in the end a multiplex approach, as one sample preparation is in common for all the seller kits, as I was presenting at the beginning. And then, so this means that the same extract can be matched on several kits with maximum flexibility. That is the company, the laboratory that decided exactly which are the toxins of interest. You can host up to 4 parallel methods in a session using the same adapters, the same racks, and the same plate frame. But the next day you can maybe use one session just for one toxin. So you have 100% flexibility. And for milk, the advantage of using the Bolt for Aflatoxin M1 analysis in milk is, in my vision, dramatic, as it is possible to analyze the milk samples without running any sample preparation. You really don't have to manipulate the materials that you receive. And it means that the analyst is really free once the samples are dropped into the tubes and inserted in the robot racks. And potentially, I would say that the analysis could be run potentially by anyone with almost no training. Then the data discussion and understanding is another thing, but the assay itself is something that could really be demanded to the instrument. And good to mention what is written here in the middle of the circle that asks for mycotoxins. Validated protocols for Bolt are available for many other contaminants from and many other ELISA solution from Eurofins technologies. So in this sense, we try to position as a real a partner that can be supportive to the routine of industries and laboratories. We can come install the instrument. The instrument belongs to Eurofins technologies as well. So we have an inside product that comes directly from our own portfolio. We have the product specialist that can support customers for the machine. And in parallel, we have the kits and we have the validated methods. The day after we go away, after installation, everything can be run without doing further adaptations or investigation or modification and so on. Plus, it is always always possible for customers to program the Bolt for any kind of ELISA test kits they wish to have hosted in the machine. So again, there is also a further degree of freedom. So I guess we have exploited our time today. I would like to thank you in advance for your attention and participation. I don't know, Evelina, did you collect further questions for me?
Yes, actually, yes, there are some questions from the audience. Since we are more or less out of time, we will start to answer the first ones, and then in case we will back to you with mails or then next days. So let's start. How can I monitor the performance of B0 sessions?
The performances of the B0 kits, I guess. So
Yeah.
Obviously, there is the zero standard where you can inspect the intensity. The intensity must always be above a certain level that is reported in the kit insert. So I do understand some companies are scared that not having the standards and not being able to monitor the right execution of the assay. But first, you have the zero standard that must have a proper intensity. Plus, my suggestion is to do a very big investment, purchase one control material and run in the session. Obviously, this is not a big investment. It's really consistent recommendation. This way, you don't just inspect the execution of the assay, but also you control the quality of the extraction that you run, if there are any contamination in the environment, and so on. So it is really good advice that keeps anyway the cost of the analysis lower than a regular ELISA with calibrators. So you have these two possibilities to monitor the performances and the quality of the session regularly in routine.
Yes, thank you. Then there's a second question that is regarding the ice cream Aflatoxin M1 milk KYC approved. And they're asking if it's applicable also to milk of other species.
Yes, the kit was approved by AUSC for the analysis of bovine milk. So for the certification, this is what we have. But recently, the researchers had joint project with here an Italian institute, and they validated together EU goat and buffalo milk with very consistent results, same LOQ at 5 nanograms per liter of Aflatoxin M1. So yes, I would say that the kit can be run with or without sample centrifugation. There is no problem and no advantage in running the centrifugation, as the performances are good anyway, also for these three species.
Okay, thanks. Then there's another question. It is quite highly specific, and it's regarding the sensitivity. So, which is the sensitivity of B0, B1 in corn and in B0, M1 in milk, if you remember that.
Okay, okay. So yes, the limit of quantification for B0 Afla B1 is the same of the seller. So the LOQ has been validated at 1 ppb of Aflatoxin B1. This is a very specific kit for B1 only. And B0 Afla M1, so the one dedicated to the milk analysis, has an LOQ of 20 nanograms per liter. If you're searching for a more sensitive solution, then the ice cream is the best option with the limit of quantification at 5 nanograms per liter.
Okay, thanks, and nice memory. Then we have to find some final questions regarding the instrument, the bot, which you present today. One is regarding the validation at the customer site, I think, because the question was, who is making validation at customer lab, customer user, or was a Aerofin supplier? So basically, who performed the validation at the customer lab?
It was the customer himself. I guess they are referring to the data that we presented. It was not belonging to the European family. It was an external customer. We agreed on the protocol. We supplied obviously the instrument and the kits, and they used their time, obviously, and they are routing samples. This was the really big value of this collaboration. Because they run in the end double time the analysis manually as per their routine and with the robot. It was their task, and they did it autonomously. We went there just for the installation, short training, and that was sufficient.
Okay, perfect. Then there is another question that's, yes, I don't know if you already have some numbers or maybe we can answer maybe later on. And what is the extra volume, dead volume for reagents volume in bot while using the bot?
It depends on the kit formats. So as soon as a laboratory decides which kind of analysis they want to run, we advise to have to order. Sometimes we gift also some spare more reagents to cover these dead volumes. It depends also on the shape of the bottles, so it's not a real number like 2 milliliters or 3 milliliters. It depends on the shape. There is one bottle in one of our kits format that has a shape for and then the dead volume is higher. But no problem, we have all these calculations. Yes, this one is really challenging and I don't know by heart, but we have a table and we can really support exactly. We know which are the dead volumes, and if extra reagents are needed, we are here to provide, obviously, to make sure that we are able to exploit the content of the kit in any case. So this is not a problem.
Yes, thanks. This one actually was very, very specific. And